Right. We are continuing with the partial fractions today. This topic is based on this partial fractions with what you call improper denominator. Partial fractions with improper numerator. Sorry, not denominator, numerator. Numerator. That means this is just like this. For example, if the power of numerator equal is equal or greater than the power of the denominator, we must divide before the partial fractions. That's a requirement. What to do? Okay, for example, from a question, before you just discuss over here, it's better to go ahead with the question and just try to understand it. So for example, if you get a question like this, x squared plus 4x minus 1, you have to divide by x squared plus 5x plus 6, right? So if you want to do this, you can understand that this is what you call simplify using partial fractions. That's a question you have to get it. Simplify using partial fraction. That's a question today. Right, let's see how to do it with it. Initially, you can understand this denominator is a multiplication of two different fractions, two different factors, that is x plus 2, other one is x plus 3. So this is the factors over here. So that means before you do any kind of simplification, you have to first do long divide, because if the power of the numerator is exactly similar to the power of the denominator. Before you do the partial fractions, you have to long divide it. X squared plus 4x minus 1 must be divided by this denominator, that is x squared plus 5x plus 6, right? Then see whether how many x squared terms are there for x squared, that is 1, that is x squared plus 5x plus 6. If you just multiply with this, then you get the answer. This is 0 minus x minus 7. Then you can write this division in this format today. This complete number is complete number is 1 plus the remainder is minus x minus 7 divided by, now I am writing this fraction with the factors, x plus 2 and x plus 3. Now I am going to simplify this today. Keep this one and just simplify this part of it. So you can write minus x minus 7 divided by x plus 2 into x plus 3. I will write this one as a over x plus 2. I'm going to split this division plus b over x plus 3. Right. Then take the LCM of from the right hand side. So that is a times of x plus 3 plus b times of x plus 2. Right. It's equals to minus x minus 7. Right. If I want to find b, you have to if you want to find a, you have to remove b. So I can just put x equals to minus 2. So it's turned up to minus 2 minus 7 is equals to a times of minus 2 plus 3. This is turned up to 0. That is a become minus 5, right? Okay. Then you can go ahead with the b. How to find b? To find b, have to remove a. That means x equals to, put minus 3 to there. That is turned up to minus 3 minus 7 is equals to a get cancels, b times of minus 3 plus 2. This is turned up to minus b is equals to plus 3, it's minus 4. So therefore b equals to 4, right? Okay. Then you can write this full fraction over here. This is 1 plus a is minus 5. So I'll just write the minus terms at the end and write 4 over. Initially we write the positive answers at the beginning. That is not, it's not a rule, but if you write it, it's kind of clear. So you can say this is 4 over x plus 3 and a is minus 5 minus 5 over x plus 2. Right. That's a way of doing it, right? Let's go for another question and see. Suppose that you want to do this way. 2x cube minus x squared plus 4x minus 5 divided by x squared minus 2x minus 3. That's it. Right. Okay. Now you can see that here this one can be factorized. But the factorized format of it is x minus 3 and x plus 1. Right. Okay. Then to do the question is simplify using partial fractions. Partial fractions. But when you're working out with this, you can understand that when you break up to partial fractions, here the denominator power of the numerator is definitely greater than the numerator. So therefore, straightforward, you cannot go into the partial fraction. Initially, we have to divide and form into a term where the power of the numerator become lower than the denominator. Therefore, initially I just divide this 2x squared, 2x cubed minus x squared plus 4x minus 5 by this one, x squared minus 2x minus 3. So you have to see whether how many x squared terms are there for 2x cubed. That is 2x. 2x into x squared is 2x cubed. 2x into minus x is minus 4x squared minus 6x. When you divide it, it's turned up to 0 plus 3x squared plus 10x minus 5. Then see whether how many x squared there are for 3x squared. That is 3. Turn up to 3x squared minus 6x plus, sorry, minus 9. Then if you just work out, this is 0 plus 16x plus 4, right? Okay. Then, yeah, that's it. Then what you can get here is that, then you can write the complete number is 2x plus 3 plus the remainder is 16x plus 4 out of, now write the denominator using these two fractions. X minus 3, x plus 1. Now we need to do the partial fraction for this bit and write the final answer. Right? We'll go ahead with that part of it. X plus 1. So you can write this is A over x plus 3 plus B over x plus 1. Right? Okay. So with that you can say 16x plus 4 is equals to A times of x plus 1 plus B times of x plus 3. Right? Okay. Then what you can get here is you can write x, you have to get a, I just have to remove this, a minus 3. 16 into minus 3 plus 4 is equals to a times of minus 3 plus 1. So it's turned up to minus 2a is equals to 6 minus 48. Minus 48 plus 4 is minus 44. That is a equals to 22, right? Okay. Then if you need to get the value for b, can make x equals to minus 1. 16 into minus 1 plus 4 is equals to b times of minus 1 plus 3. So that is turned up to 2b is equals to minus 16 plus 4 is minus 12. Therefore, b is equals to minus 6 with it, right? Okay. Then you can write this is this way 2x plus 3. The final answer is 2x plus is a complete number plus a is 22 over x plus 3 and b is minus 6. Minus 6 over x plus 1. That's the answer where we need to get it. That's a way of doing this kind of a question. Right. Let's go ahead with another question. That is this way. 4x cubed plus minus 2x squared minus 3x plus 1 divided by x squared plus 2x plus 1. Now what you can understand is here, this is x plus 1 into x plus 1, that is x plus 1 squared. That's it. So initially, if you want to simplify use the partial fraction, here the same thing we need to do because the power of the numerator is bigger. If it is less, not a problem. If it is bigger, you have to definitely, you have to use the partial, sorry, you have to use the long division and simplify first before you do the partial fraction. There is a requirement with it. X squared plus 2x plus 1. So it's turned up to 4x cubed plus 8x squared plus 4x. If you subtract, it's turned up to 0, minus 10x squared minus 7x plus 1, that is minus 10, minus 10x squared minus 20x minus 10. If you subtract, it's turned up to 0, plus 13x minus, sorry, plus 11. So you can write the final answer, 4x minus 10 plus 13x plus 11 over x plus 1 squared. Okay. Then you need to do the partial fraction for this. 13x plus 11 over x plus 1 squared. You know that if you get a power, some kind of a term which is having a higher order, you write with the all the minimal orders and simplify with it. Yeah, let's see how to do this question. But then you can say, you take the LCM, this is turned up to a times of x plus 1 plus b is equals to 13x plus 11. If you want to find b, what you can get here is that you can make x, you have to remove x equals to minus 1. Then what you get? 13 into minus 1 plus 11 is equals to, this is can get cancels and turn up to b only. So it's turn up to b become minus 13 plus 11 is minus 2. If you want to get a, you can substitute another figure and get the equation. 0 13 times of 0 plus 11 is equals to a times of 0 plus 1 plus b. So you know that this is turn up to 11. This is a, b is minus 2. So you can say a become then 13. Then you can write the final answer, a is 13. So you can write this is 4x minus 10 plus 13 over x plus 1 and constant b is turn up to minus 2, right? So you can say minus 2 over x plus 1 squared. That's a way of doing this kind of a question. Okay, so I'll just make it a little bit small, then you can see the entire question at once. That is that question. This is this, and that's a way of doing this kind of questions, right? So you can finish up this entire, what do you call that?